Hello guys, welcome back to algebra class. So this time we are going to learn about exponential function. And this is the basic concept of exponential function. So in your note, make sure to grow this, like write down exponential growth, and then write these 4 sections, okay? In exponential function, we can usually represent this one in equation, table, in a real world example, and graph. And these concepts are fairly easy, so let's get started. So exponential function, we have basic form y equals a times b to the x power. So as you can see, we have x as an exponent, okay? Write this one down. And for a, we call it initial value. Okay. And for b here, for b, we call it base. All right. Now, in order to be exponential function, base should be greater than 1. Okay. If base is not greater than 1, then there is no growth in it. All right. And another name of initial value, we also call it the starting point. So you have to memorize this basic form, okay? So usually in exponential function, you have to learn how to find equation and then find answer, okay? So let's write the rule of the exponential function. So here, do you see any patterns? I mean, for x values, we just do -2, -1, 0, 1, 2. Like you can see it increased by 1. But what about these y values? Fraction, well, we are not really familiar with fractions. So let's look at the numbers. 2 to 8 and 8 to 32. What happens? Do you see these are multiples of 4? That's what you have to know. So these multiples of 4, they're all multiples of 4. We call it a rate, okay? And this is gonna be our base. So as you can see here, we have exponential function. So now we know how to find base. But what about the starting point, which means initial value? In order to find initial value, we have to look at where x is equal to 0. So let's look at where x is equal to 0, which is 2. This is going to be our initial value. Okay. So our equation is going to be y equals 2 times, that's initial value. Our rate is going to be what? 4, right? 4 to the x power. Let me put parentheses. This is going to be our equation for this one. So y equals a times b to the x power. A is going to be our initial value, which is 2, and b is our rate, which is 4. Okay. Now let's go to the real world example. You deposit $4,500 in an account that pays 5% interest compounded annually. So if you invest money into the bank, obviously you're going to get money over time, right? In this question, they give you 5% annually, which means every year. Now we have to write an equation that represents this scenario, like this exponential function. So first, we gotta find, always we have to find initial value, which is the starting point, and then rate, okay? So where do we start? At the beginning, we invested like we deposited $4,500. So that's gonna be our initial value because that's where we start. After that, as you can see, they pay you 5% interest, right? Now, if you see percentage, like percent, you always have to do 1 plus because it's gonna increase, right? So you gotta do 1 plus 5%. Now, how can we change percent into decimals? 5% is 0.05. So our base in this case is gonna be 1.05. All right? So we got everything, like y equals a times b to the x power, right? So let's put this one in. Instead of a, we're gonna put 4,500 because these are 4,500 is our initial initial value, and our base is gonna be 1.05. Again, our base is greater than 1 because it's greater than 1, right? Bigger than 1. So that's increasing. So here we go. This is going to be our equation. Okay. All right. Let's do the graph here. Now we gotta find, again, you have to know, we have to find A, which is starting point, B, which is our rate, and y equals a times b to the x power, right? So A is starting point, and just like here, you have to find where x is equal to 0. So this point, this is going to be our starting point between 4 and 5, right? So y-intercept, that's going to be our initial value. So it's going to be 5. Now let's talk about b. How much does it increase? It moved 5 to 10 and 10 to 20. Just like times by 2, isn't it? It's not percentage, it's multiplied by 2, so you will just write 2. And obviously 2 is greater than 1, right? So it's going to be increasing. So let's rewrite our equation here. Y equals a is 5 times our base is 2 to the x power. So that's it. Exponential growth. Now let's talk about exponential decay here. What about exponential decay? We use it when things are decreasing. So same thing here. A, we call it initial value. And x is what? We call it exponent, obviously. And for b, we call it base. But in this case, we call it decay, which means decreasing when b is less than 1. So if b is greater than 1, that's going to be growth. If b is less than 1, then we call it decay. It's not two separate equations. It's exactly same equation. Just what you have to know is this b, if this number is greater than 1, then we call it growth. If these numbers are like smaller than 1, then we call it decay. You will see here. Let's go to the table first. Our initial value, where x is equal to 0, it's 9 here, right? So we already know a is equal to 9. Now let's look at this. 9 to 3, 3 to 1, 27 to 9, 81 to 3. I mean, it's kind of obvious that it's gonna be like 9 divided by 3 is 3. 3 divided by 3 is 1. Like, it's divided by 3, right? But we cannot really use divide. It should be multiplication. So what's another way of writing like divide by 3 in multiplication? If you're not sure about it, you can always write second number, like number on the right, divide by first number. Like it does not have to be like these two numbers. It should be like any number. Like always second number divided by first number, okay? Let me try 27 and 81. 27 divided by 81. 1 over 3. So it's gonna be multiplied by 1 over 3. Let's check again. Let's try 9 and 27. So always number on the right first. 9 divided by 27. Yep, it's 1 over 3 again. Let's try 3 and 9. 3 divided by 9. Yep, it's 1 over 3, right? That's how you find base. So base is gonna be 1/3. For the exponential equation, it's same thing. If you look at second number divided by first number, like 32 divided by 8, you will get 4. Do you see this 4 we got here? So it works all the time, all right? So we got initial value and base, which means we can now find equation, which is y equals a, which is 9, times 1 over 3 to the x power. This is going to be our exponential equation. And as you can see, 1 over 3 is smaller than 1. That's why we call it exponential decay. All right, let's do a real world example here. A car was purchased for $18,000. So you buy a car and you paid $18,000. That's fair price for the new car. Okay. The car depreciates by 20% each year. So car's value will decrease 20%. Depreciate. If it starts with D, that means it decrease. Decrease by 20% each year. So we have to write an exponential function to model this scenario. Okay? So first, we have to find initial value. What is that going to be? We first used $18,000. That's the money that you put to purchase, right? So that's going to be our initial value, which is A equals $18,000. B. Now it says we have to look at the word carefully. It says depreciate. As you can see here, it's compound annually. Compound annually means like increase. Depreciate means decrease by how many percent? 20%. So whenever you see this like the percentage, you have to change this one into decimals. But I'll tell you something specific later. Since it is decreasing, you have to write not 1 plus, you have to write 1 minus 20%. If you don't see like percentage, you can just write 20 here, but that's not gonna be the case in this here. So 1 minus 20%. So 20%, if you change it to decimal, it's gonna be 0.2. 1 minus 0.2 is 0.8, right? Which makes sense, 0.8. This is less than 1, right? Therefore, this one is decay. So y equals $18,000, and your price of the car will decrease by 20% every year, like this. So this is going to be the equation for this exponential function, okay? Last, let's look at this graph. As you can see, this graph is decreasing, right? So our initial value, always y-intercept, where this x is equal to 0. So a is gonna be 4. So let's look at b. 16 changed to 8. 8 changed to 4, right? And 4 changed to like 2. Yeah, this 2. And this 2 changed to like 1 here. So as you can see, it's decreased by 1/2, isn't it? If you cannot see, always you can do second number, like number on the right, divide by number on the left. Like number on the right, divide by number on the left, okay? So, same thing here, y equals, like here, y equals a times b to the x power. So y equals a is 4 times b, which is 1/2, smaller than 1, to the x power. So do you see these numbers are smaller than 1? That's why we call it decay. And here numbers are bigger than 1, so that's why we call it growth. So these are basics of exponential equation, and I hope this video helped. See you guys.